Hey everybody, it's Dr. Schulman, and we're flying through algebra. This is my this is one, two, three. This is the fifth video on it. We're going to do 5A, which is linear equations and inequalities, which we've done tons of. We've done tons of these already. Part A is like finding patterns, like strategies for finding patterns, and part B, we're just going to do tons of inequalities. Um, Pattern stuff happens a lot. The best way to think about it is just like how can we make the equation from the pattern? I'll share a couple ideas, just a couple quick examples if you'd like. And then we're gonna jump into inequality. So this stuff is pretty interesting. I like the fact that we're gonna do inequality stuff. I think showing students like how to graph them. So in the next video, like I'll share a worksheet where it's like you actually get to see the graphs like emerge. So you usually have like th two lines and where they intersect is the answer, but like because it's an inequality, you get to shade the sides, so that should be really fun. But we're gonna just start with just like some basic pattern ideas before we get into it. So I'm sharing my screen if it lets me. There we go. So we're here. Again, math for teachers, instruction, algebra, linear equations, and we're here for 5, which is this is what it's called, linear equations and inequalities. We'll do inequalities all for B, but basically this is just knowing a pattern, write the equation to represent that pattern. So this stuff comes up a ton, okay? Um, they could be easy, they could be hard. It could be like 1, 3, 5, 7, 9. So what is this pattern, right? Well, you can think about it that we're adding 2 every time. So we'll know what the next one in the pattern is, right? But what is an equation that does it, right? How can we represent all of them? So that's usually where the stuff gets a little tricky. It's like, how do we write an equation for this? Because if I just do y, our output, right? So our first one has to be 1. Our second one has to be 2. This is your input, and that's your output. Our third term is 5. Let me move my weird floating head. The fourth term is 7. The fifth term is 9. So if we just do y equals x plus 2, will that work? No, because look, 1 it should give us 1. It doesn't work, right? 1 plus 1 is 3, so that doesn't work. Well, what if we do y equals, I don't know. What if we put it here? What if we put the 2x here, right? And so, okay, so then 1 time, this won't work either because 1 times 2 is 2. It still doesn't work. So what if we do 2x, I don't know, 2x minus 1. Let's see if that works. Well, 1 times 1 is 2 minus 1 is 1. All right. 2 times 2 is 4. 4 minus 1 is, yeah, that works. Let's try the middle one. All right, we should get 5. 2 times 3 minus 1. 5 equals 6 minus 1. Yeah, 5 equals 5. So this is the equation of what we just made. Usually there's a subtraction case because a lot of times the pattern doesn't start with 0, it starts with 1. Sometimes it can be really tricky. Like, what if it's 1? I have crazier ones, but I'm sure they have them in Desmos. Let me just make up a one right here. All right. What if it goes 1, 8, 1, 8, 27, 64? What's the next one on the pattern? But you can be like, okay, it's plus 6, and this one's plus 21. Sorry, 27 minus 8 is 19. And this one is, let me make sure I did that right since I was dividing so badly in the last video. Cool. And 64 minus 27 is 37. Okay. Well, it could be a two-stepper, right? Sometimes it's a two-stepper. I can see the pattern, but if you can't see it, that's okay. Well, this is plus 19 minus 6, because it doesn't just, so there's 2 types of series. Adding is what you'll probably see in elementary school. Adding patterns are called geometric. Sorry, arithmetic. just so you know kind of where we're going. Arithmetic is like add patterns, and geometric is multiply. And I'll give you a little thing for that. But let's see. So let's do this one. So 19 minus 6 is 13, right? And what's 37 minus 19? 18. So we went up 13 here, 18 here. Do you think maybe this one's going to be plus 5 more, 23? I don't know, but we can try it, right? 37, this is a two-step pattern, is 60. And what's 37 plus 60? It's 97. It's not the answer. The actual answer is 125. So we can't use this method. What is the pattern? Well, this is 2 cubed. This is 1 cubed, 2 cubed, 3 cubed, 4 cubed, and 5 cubed. So if we were to write it out, right? This is our x. So our x is 1, 2, 3, 4, 5. We can think about the pattern as y equals, well, we know it's going to be x to the third. Does that work for all of them? 5 to the third is 25. Yep. So this one, we don't have a -1, but it's just to the third for every single one of them. So finding these linear equations, this is a cubic equation, so it's just ones I thought of. But finding the patterns, usually you add to, or you see about a double line, but getting the equations is going to be the hard part. If you want practice with arithmetic and geometric sequences, I'm sure I've got a good one for sequences and series. Yeah. So here's a fun grab bag you can use for your students. I'll put it in the thing if you want to try it. Here, let me copy that. And let me go to where we are here in the modules. Just so you can see some more patterns. So here's if you want to see some harder patterns, I'll do a couple of them just to show you the formulas. Just so you get a better sense of what they are. Oops, it didn't save. If you want the notes too, that's fine. There we go. All right, so I might as well do a couple of these before we get started. Let me download this. This is a grab bag. They're super fun for students. Basically, you cut it into little pieces, and the students pick rookies, mediums, or all-stars. But let's just download this as a PDF so I can draw on it for a second, then we'll get into it. Yours aren't going to be this hard, but I just thought I would just show you some of these. Okay, so here we go. Well, 2, 4, 6. What are we doing? We are adding 2 each time, which is 8, 10, 12. But what is the equation going to be? Y equals, we're going up 2 every time. Is it going to be x plus 2? Well, that's our first term, second term, third term, fourth term, fifth term, sixth term, right? If I just do 2 times x, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. Yeah, that works. This one we are minusing 10 every time. So that's 75, 65, 55. This one we are adding 3 every time. And think about what the equations would be. So that's going to be 5, 8, 11. This one we're minusing 7 every time. That's going to be -3, -10, -17. And this is the equations. So this is how you would write it. So it's always going to be the first term. All right. This is to get whatever term you want in the pattern. So our first term is 2 plus n minus 1, and I believe it's times the difference. And our difference is 2 here. So let's say we want the fourth term. We know it's going to be 8. So let's say we want a to the fourth. This is 2 plus 4 minus 1 times 2. All right, so a to the fourth should be 2 plus, well, what's 4 minus 1? 3. What's 3 times 2 is 6. What is 2 plus 6? We got it. It's 8. So this is how you can get, if they ask you for like the 50th term, guess what? You put a 50 here, we're good to go. All right, so this one, we have 100. And we want n minus 1, and this one we're minusing 10 every time. So our difference is a negative 10. So let's say we want the 1, 2, 3, the fourth term, right? The fourth term, which we know is 75. So we want a subscript 4. So that's 100 plus 4 minus 1 times a negative 10, right? So here we go. A to the fourth equals 100. 4 minus 1 is 3 times a negative 10. Negative 10 is negative 30. 100 plus a negative 30 is 70. We wanted 75 though. 100, oh, it's minus 5. Minus 10. Oh, so this one's off. This one's minus 10, minus 10, minus, but this one starts with 100. So this is a different pattern. This was 105, it'd be different. I think it might be a typo, but notice that the pattern goes 5, 10. This one's got to be 15. And that's why, but it still would be off. So 5, 10, 15. So this one is different because it's going by a different multiple. You can't use the formula unless there was a 105 here. Sure, it was a typo. All right, here they just want the difference. They just want to write the formula. So we can do this one. We are adding 2 every time. So a to the n equals negative 7 plus 7. And if this was 105, like it should have been, this would have been the answer. N minus 1, positive 2. So let's say we want the fourth term, which would be a negative 1. So our fourth term, a to the fourth, negative 7 plus 4 minus 1 times 2. What's negative 7 plus 3 times 2 is 6. Negative 7 plus 6 is negative 1. Cool. So these were just the rookie ones. These were easier. Find the 16th term of the pattern. We would literally just put a 16 here and solve. Find the 23rd term of the pattern. These are still off. This should be 105. That's okay. So there's a little mistake in this one. Ooh, so then there's also another formula. So if they ever ask you to find the sum of terms, so sometimes then when you ask you to all add them all up, there's another formula. So it's just the first term. So plus the last term. So all you have to do is get that first term plus the last term and use it. I know it's like this is kind of harder than what you're working in, but these are good. Ooh, let's do some of these. These patterns are fun. So how can I go from 10 to 30 when I'm working 3 spaces? So that's 1, 2, 3, 4. So 15, 20, 25. This is going up by 5 every time. But there's obviously math you can use. There's equations you can use. So this is 3. We can go negative 1, positive 1, 3. Not enough. All right, so we have to go 1, 2, 3, 4 spaces, and we have to figure out what these are going to be. So if I go up 3, so it'd be 0, 3, 6, 9. Yeah, it's 3 every time. So 0, 3, 6, 9. How many terms are in the sequence? Use for a to the n and then solve for n. Well, we might as well just do one of these cool patterns. So let's do one more. So how many terms are there in the sequence? So we're going from 83 to 5, right? These are the same. I don't know why they doubled. I guess it's not the best one, but you could, it's made to cut them up. So here we go. The a to the n formula, which is right here, a to the 1 n minus 1 times d. A to the n equals a to the 1 n minus 1 because we need one for the first one times d. And I'm pretty sure it's added, right? Yeah, it's added. So for this one, we just have to find it. So we're looking for how many terms there are. So we don't have the n. We have our last, we know what a to the n is. The term we want to find is 5. Our first term is 83. We don't know what this is, but we know the difference. We're just adding, oh, sorry, subtracting 3 every time. So instead of writing them all out, which would be a pain, right? That's why we can use the formula. I'll do it in this box. A to the n equals a to the 1 plus n minus 1 times d. Good thing there's no geometric ones in here because that's a different formula, which is fine. If you want to know more, just email me. So we know that we end at 5. That's our last term. Our first term is 83. We're looking for n, and our difference is -3. So 5 equals 83 plus, well, -3, and a minus is a +3. So -3n plus 3. 83 plus 3 is 86. We're going to minus 86 from both sides. Going to give us a -81 equals -3n. How do we know 3 goes in? Because 8 plus 1 is 9, and 3 goes into it. So 3 goes into 8 2 times. 3 goes, so it's 27 terms. This means it will be 27 terms to start at 83 and go all the way to 5. If you want more stuff about sequence and series, just reach out. I think it's time. I think that's enough pattern stuff before we really get into it. But let's start. So I'm in delta. Here's 5a. Let's make it happen. Hope that was a good like little intro. I hope it was not too hard. So are we in the right place? Last one is inequalities. Yeah, here we go. All right, let's understand linear stuff with lines from different ways. Company orders box lunches from a deli, which all cost the same price. The relationship between the number of box lunches, X, and the cost is Y. So what does this mean? This means if I sold 3 box lunches, it's going to cost me $27. No, not each. Total $27. Boom. Nice. X is the input. Y is the output. Nice, easy way to start. All right, second level. Line TR represents the proportional relationship. Okay, point T lies at 10, 12. Which ordered pair could represent a point for R? So basically, they're telling me I have this TR, and it's in a proportional relationship. So I have 10 for X and 12 for Y. So a good way I can think about it is we just divide this by 2 because they're both even. I believe 5, 6 will work for me. I believe 5, 6 will also work. That is not a choice. 5, 6 is no choice of ours. So we got to figure it out. We just need to have something that's also going to be the same slope. So if we have 2, 0, 1.20. So I don't think the first 2 work. So we could either be 15, 12 and a half, or 12 and a half, 15. I'm pretty sure it's C or D. So let's see which one makes sense for us. I'm going to find the constant. I didn't do this last video, but you always can. So here we go. Y equals KX. So 12 equals 10. Sorry. Yeah, it's 10 times K. Divide by 10. And 12 divided by 10 is 1.2. Oh, so I have 1.2 equals K. So let's see if it works. I'm pretty sure it's going to be D. I'm pretty sure 12.5 equals sorry, I put the y in the wrong place. So 15 equals 12.5 times 1.2. If I put this x and this y, I should get the answer. Let's try it. 12.5 times 1.2. Is this going to give me the 15 we want? It does. So it works out for us. So they are proportional. You could also do a cross multiply, which would be 10 over 12, right? Equals 12.5 over x. And if we cross multiplied, you would see that this has to be 15. That's probably the way I would do it. But I'm trying to show a bunch of ways. That's what they wanted. Oh, they checked them all. Wild. I didn't check them all. I just checked the one I thought was right. All right, let's graph a story. Here we go. Eva left her house at time 0 and drove for 3 minutes to the store at a speed of 1 block per minute. Okay, so I'm going to do this step by step. There's so much here. Eva left her house at time 0 and drove for 3 minutes at 1 block per minute. So ready? 1 block per minute, so we're starting here, 1 block per minute, 1 block per minute, 1 block per minute. That's our first part. Then she stopped and went in the store for 5 minutes. So for 5 minutes, we're not going anywhere. So ready? 1, 2, 1, 2, 3, 4, 5. Okay, cool. From there, she drove in the same direction for 5 blocks until she drove in the same direction at a speed of 5 blocks per minute until she got to the bank 15 blocks away. Okay, so now we're going 5 blocks per minute and we want to go 15. So that's going to be it. In the course of 3 minutes, we're going 5 each. So you ready? So we're here at 3. So 3 plus 5 is 8. Boom. All right. All right. 3 plus 1, 2, 3, 4, 5. Well, how do I get rid of this guy? Get rid of you. I think if I just click it, it goes away, right? Come on, be my friend. All right, well, I'm just going to reset it and start over. It's kind of annoying. I was halfway done. All right, let's do it again. A 0, 1, 2, 3. And we wait there for how long? 5 minutes. So I'm going to write it down so I know exactly where I'm going. So we're at 8, 3. And we want to go 5 blocks per minute for 15. So 8, 3. So we want to go plus 5, plus 1, plus 5, plus 5, plus 1, plus 1. So this is plus 15. 8 plus 15, considering I messed up before. It's 23. And then 3 plus 3 is 6. So I shouldn't go. I have to be here. Oh, but it's the other way. So in the case of we're going 11 because this is the time. So we're only going 3 minutes. So that's 11. And then 3 plus 15 is 18. Right? Until she got to the bank that was 15 blocks away. And there she drove at a speed of 5 blocks per minute until she got to the bank that's 5 blocks away. Because 15 divided by 5 is 3. That's why we're only going in 3 minutes. 11. And I gotta go all the way up to 18. Or I can just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Boom. Boom. You stopped at the bank for 4 minutes. 1, 2, 3, 4. Okay, and then she drove home at a speed of 2 blocks per every minute. So 2 blocks per every minute. 2 blocks per every minute. 2 blocks per every minute. We got to go all the way home. Pretty sure this is how they want it to look. Ta-da. Click twice to plot. Click a segment to delete. It didn't work when I did it. Oh yeah, I was clicking the dot, not the segment. Okay, well, whatever. I think this is the answer. Oh, beautiful. Cool. So that was tough. Yeah. Yeah. Oh, see, always put what you want on top, 1 minute, what you have on the bottom, so it cancels. Remember that from the conversion lesson every time. I guess I was just doing that all in my head. All right, let's keep it going. These are nice and easy. Well, I think these are easier. These make more sense to me. So we just did graph stories level 1, graph stories level 2. Okay, it's going to get harder. Who would have thought? I thought the first one was pretty hard. On a spring day, Sebastian noted the time of day and temperature in degrees Fahrenheit. His findings follows. At 6 a.m., it was 52 degrees. All right. For the next 3 hours, the temperature rose at 1 degree per hour. So you got 3 hours. So we're going to 9 a.m. We're going 1 degree per hour. So ready? This is 3, 1 degree per hour. So 50, 55. For the next 4 hours, so that's 10, 11, 12, 1 p.m. Okay. It rose 4 degrees per hour. So we're going 4 and 4. So we're talking 4 times 4. We're going 16 degrees. So we're at 71 degrees. Temperature then stayed steady until 6 p.m. So at 5 hours, so we're going to go to 6 p.m. and it's the same, still 71 degrees. All right. For the next 4 hours, so until 10 p.m., the temperature dropped 2. So what's 2 times 4? 8. So 71 minus 8 is 63 degrees. And the temperature then drops steadily until the temperature was 62 degrees at midnight. Okay, so at the end, we're at 63 degrees. We're saying from 10 p.m. to midnight, we got to go just how many degrees? Just 1 degree. So it's going to be half. So 62 degrees. So we have all the points we need to plot. We should be good to go. I did a point by point. You can do the conversions if you want. So remember this hash mark right here? This hash mark right here just means they can start at 50. So the first one is 6 a.m. We're at 50, 51, 52. The next one is 9 a.m. So 6, 7, 8, 9. So at 9 a.m., we are at 55. Okay. And then at 1 p.m., at 1 p.m., we are at 71. Cool. And then at 6 p.m., we are still at 71. So at 6 p.m., we are still at 71. And then we start going down. All right, so now at 10 p.m., 12, 11, 10 p.m., we're at 63. So I believe that's 61, 2, 3. And now all I have to do is in 2 hours, I just have to get to 62. So ready, 60, 61, 62. Boom. In 2 hours, I went 1 degree. I believe that's it. That was crazy. Ta-da! There's our conversions. I liked my way. You can do the conversion way all you want. That's totally fine. Ours looks just like theirs. Cool. Let's interpret a story. All right, let's see what's going on, girl. Stella left her house and drove to the store. She stopped and went inside. From there, she drove in the same direction. She stopped and went inside. From there, she drove in the same direction until she got to the bank. She stopped inside the bank. Then she drove home. Cool. There's the picture. How long was Stella in the store? Well, we're going minutes. 1 minute, 2 minute, 3 minute, 4 minute, 5 minutes, 6. She was in there for 7 minutes. Great picture. All right, let's find some patterns. Here we go. This is what they really want us to do. 13. So this is, we can do an equation too, right? Let's make an equation for this when we're done. 6, 6, 6, 6. So our answer is 37. Let's write the equation, right? Y equals mx plus b. This is drawing it as a line. It's a linear equation, right? We can use those ones I showed before. Let's just pick the third one. So 25 equals something times x plus, I don't know, right? What are we going up by every time? Looks like we're going up by 6. Well, 6 times 3, right? Right, because our point is 25, 3. 6 times 3 is 18. Is it this? Is it y equals 6x plus 7? Is that what it is? Let's try 1. All right, let's try the first one. 6 and 6 plus 7. Yeah, it works. 2, 12 plus 7. Yeah, there's the equation. So this is the equation of the line we just made. Based on this, everything will work. All right, well, sometimes you just got to redo it. So here we go. We know it's 37, and we know the equation. In case they ask for it, which they probably will. Oh, that means I got to find it again, which is okay. Edit, assignments, 5A, edit, skills. All right, identifying a function from points. Cool. So when they're talking about identifying a function, I just put this in because it's good to know for students and for algebra. A function just means no double x's. Guess what? If you have 2 ex-girlfriends, that is no fun, especially if they're on the same graph. So this is a function. It passes what's called the vertical line test. Every x is different. This is also a function. This happy face passes the vertical line test. It only hits it at one place. It's not a one-to-one function. This is one-to-one. This means all x's and y's are unique. A function just means all y's are unique. This is one that's not a function. I draw a line, it hits it at 2 places, not a function. So we just can't have 2 x's that are the same for it to be a function. Let's figure it out. X's are different. X's are different. X's are the same. So oh no, x's are different. Okay, so all these are different. Oh, but they said a linear function. So they're talking about it's got to be a straight line, which means all the slopes have to match. 1, 2, 3, 4. This is -3, -3, -3. I like D. This is +4 goes down 1. I'll show you what I'm doing. So the first one looked like this. 1, 2, 3, 4. 4, 1, -2, -5. +1, -3. +1, -3. +1, -3. That's why I knew this was the right answer. It's a straight line. It goes like that. It's beautiful. The next one, -8, -4, 2, 8. We have 8, 7, 4, 1. So this one is plus 4 minus 1. This one is plus 4 minus 3. See, this would have to go by the same rate. It doesn't have to be perfect, right? This could be 2 and 6, right? This one's plus 6 minus 3. So this one, this point and this point would work, but not all of them. I'll show you one more. Well, it's D, but let's just see another one. Oh, they found the slopes. Every slope's the same. Every slope's the same. It's a straight line. So you can find all the slopes too. That's a good way to do it. All right, let's keep it. Increasing and decreasing. The graph of the function is shown below. What is true about the function from x equals 5 to x equals 9? It is decreasing and linear. It's going down and it's in a straight line. We can do another one too, just for the fun of it. From -4 to 0. This is not a straight line, but it's still decreasing. Decreasing and non-linear. So these are not straight lines. It's a curved line, but it is decreasing. Remember, always down, decreasing, increasing. All right, let's table to linear equation. Yeah, this is what I was talking about. I thought they'd give us at some point. All right, so let's figure it out. Y equals mx plus b. We're doing what? Adding 1 every time. This one we're adding 2. So this looks like it's a 2 slope of 2. And let's pick a point in the middle. So when I have 2, my y is -1. So -1 equals 2 times 2 plus b. -1 equals 4 plus b minus the 4 minus the 4. B equals -5. And guess what? There's our intercept right here. See, if it was 0, we'd have the -5. 2x minus 5, and you can tell it's increasing as this is positive, which means we should have a positive slope. I'm sure they're going to draw us a pretty picture too. What? They didn't draw the picture? Well, there's only one way to change that. 0, -5. There's your first. Oh, I need these guys. 1, -3. Might as well do the points. 2, -1. 3, 1. And finally 4, 3. All right, there's the line, and there's the points, and here's the line they didn't give you. Y equals 2x. And then we have to drop it so it matches. Ta-da! Beautiful. Ooh, they get harder. All right, well, we're not going to graph it. We graph one of them. So the x is still going up. This is getting more negative, so we have a negative slope. Y equals mx plus b. The slope is just minusing 2 every time, so I'm pretty sure if we did -2, we should be fine, right? So y equals, well, if you're not sure how to find the slope, this is the right way to find the slope. So our slope is change in y over change in x, which is y2 minus y1. Sorry, y2 minus y1 over x2 minus x1. So we'll just pick the first 2 points. Well, actually, let's pick the second 2 just for fun. So -10 minus a -8 over 4 minus 3. So it's over 1. -10 minus is plus 8. So it's -2. So I was right. The slope is -2 every time. You can see because it's just going up by 1, like the other one. So -2x plus b. And we could just take our first point. So this is going to be a -4 equals a -2 times 1 plus b. -4 equals -2 plus b. Add the 2 to both sides. What's your y-intercept? B is -2. And it makes sense. Look, 10, 8, 6, 4, -2, 0. That's why we know the y-intercept where it hits has to be -2. So y equals -2x minus 2. And I'm glad we're going to go even harder because this one was still kind of easy. They wanted the slope. We found the slope. We plugged it in to get the intercept. Oh, they did the pattern way, which is fine. We did the equation way. All right, here's one that's even harder. All right, let's make it happen. I don't know where the zero is. The zero is somewhere between 7 and -18. Let's take the top two, just for fun. 57 minus 32. It's going up, so it's going to be positive at least. 11 minus 6. So we got 5 on the bottom. 7 minus 2 is 5. 5 minus 3 is 2. So our slope is going to be 5 positive, or 5/1. Y equals mx plus b. There's where the 5 goes. Let's pick the first point. So that's 7 equals 5 times 1 plus b. 7 equals 5 plus b minus 5 minus 5. B is 2. And there's your equation. Y equals 5x plus 2. You could plug anyone in. 5 times 1 times 5 is 5 plus 2 is 7. 5 times 6 is 30 plus 2 is 32. You can check it if you like. Nice. All right, let's keep on going. Yeah, I knew there weren't a lot on this one. So here we go. The graph of the function is shown below. So we just need the slope. So we've done this a ton, but remember, changing y, we're changing x. You need perfect crosses, a perfect cross to get it. Here's a perfect cross. Here's a perfect cross. We're just going to count. We're going to rise up 1, 2, 3. Wait, is that perfect? Nope, the perfect one is here. So this piece and the 4. So 1, 2, 3, 4, 5/1. The slope is 5. Feel free to count if you want to count. Oh, 5/1. Changing y over changing x. Right. Here we go. Which of the relationships represents this function? Okay, so we got some choices. So this is -5. It's got to hit at -5. This guy's out. This guy works, -5, and the slope is +5. Up 5, 1, 2, 3, 4, 5/1. Nope, this one's off too. So A and C are out, which is okay. Let's just plug one in. This is 2 to 8. 5 times 2 is 10. 10 minus 5 is not 8. It's got to be D. I guess we can use 6. 6 times 5 is 30. 30 minus 5 is 34. What? Oh, it's just the same slope. Okay. Which one also has the slope of +5? 1, 2, 3, 4, 5/1. Not this one. This one's negative. What is the slope of this one? We go up. This is change in y. 8 minus a -2 over change in x, which is 2 minus a -2. 2 plus 2 is 4. 10/4 is not 5. It's got to be D. All right. 54 minus 34 is 20. 10 minus 6 is 4. 20/4 is 5. It's D. What a tough question. Oh, they did exactly what I did. They found all the ones that were wrong first. All right, let's find this rate in context. Fulton is saving money each week. His savings are represented by this. His rate of change is slopes. The slope's right here. How much per week? It's +$5 per week. That's what it means. That's where the money is. That's the change. He started with $12. He's making $5 a week. So let's compare some. All right. Two friends, we got Paisley and Carson, took summer jobs. The graph below presents Paisley's earnings. 10 hours, 199, 20 hours, 398. And here's Carson's 10 hours, 242, 20 hours, 484. Carson's killing it. So it's more than, but we want it per hour, right? So we can figure out the slope right here. It's hard to see it, right? So we can do the change if you want, right? We can find both slopes and figure it out. That's the way they want you to do it. 398 minus 199 over 20 minus 10 over 10. 398 minus 199. Then we move it over one place. She's making $19.09. And then we got to do our boy, Carson, 242 minus 121 divided by 5. Our boy Carson's making $24.20 minus $19.90. And it's $4.30 more. Good question. Sweet. So we found his, $24.20. We found hers, $19.90. Oh, we could have just done it with 0, 0 and just divided by 10. That would have made so much more sense. Much faster way. I did it from here to here. They did it from there to there. All right, let's keep on trucking. Let's find the slope graphically. All right. What's the slope? So it's not a rise over run. All right, so we need a rise line. So I need a perfect point. There we go. There's the rise line. And there's the perfect cross is here. So it's going to be 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Really? Is it just 1 over 5? It is 1 over 5. So it's negative 1/5. I did mine 2 over 10, but it's really 2 over 10 is 1 over 5. Ta-da! Perfect. All right, let's keep on going. Oops. Let's find the slope for some points. We've done this before. Change in y over change in x. We've got negative not, oh, sorry. Should always be y2, just because that's what the formula is. Minus a minus 9 over negative 24 minus 1. So the bottom's negative 25. The top, we're going to add this. What is that, 13? Negative 13. Negative 15? I don't know why I'm having some moments. It is pretty hot. Okay, so negative 15 over negative 25. We can divide top and bottom by 5. It's going to be a positive 3/5. There's your slope. Ta-da! All right, let's graph a line from an equation. So there's your minus 2. And our slope is just 1 over 1. There's nothing there. Imagine a 1 and a 1. So there she is. Okay. Now we got to write the equation for the line. Y equals mx plus b. So it's the minus 8. Y equals something x minus 8. Let's find the slope. We go down 1, 2. We go over 1, 2, 3. So it's negative. It's going down, left to right. Negative 2/3 x minus 8. Ta-da! Nice. Okay, so if we want this one, we just have to get the y alone. 3x plus 3y equals 24. We want to move this over, so I'm going to subtract the 3x from both sides. So I've got 3y. It's not 21x. You can't subtract them. You can only multiply and divide them. So it's a negative 3x. So let's put it in order. Divided by 3. We're going to do the lotus flower. Negative 3 over 3 is negative x. And 24 over 3 is plus 8. You can put them both on the graph. Show your students that they're the same. Negative x plus 8. And let's keep on going. Ours looks exactly like theirs. What is the equation of the line that passes through? Lines from point slope diagonally. All right, we're not going to do this one because we don't need just the diagonal. There we go. Lines from point slope. Let's do it. It's just the same question twice. Doesn't just have to be diagonal. All right. I want you to have a chance of getting other ones if you want to do more. All right. So we want y equals mx plus b, but we don't have the b, but we have the slope. So y equals, our slope is 5x plus b. So we have the points -1 and -6. That's your x. That's your y. So our y is -6. Our x is -1 plus b. We have -6 equals -5 plus b. We add the 5. What's a -6 plus 5? That is going to be a what? -1. So it's going to be y equals 5x minus 1. If it was 0, there wouldn't be any, right? You'll see when you plug it in if it's going to be something different. 5x minus 1. Beautiful. There's the graph. Okay, now we have to use point slope form. It is what it is. So point slope form is y2 minus y1 equals m x2 minus x1. Then there's the standard form. Oh, I should give you these. So if you want all the different forms, I'll put them in. I think it's right. Is it line practice? Nope. Is it the slopes? No. Food equations? No. I just had it. Did I delete it? Here it is. Cool. So I'll get this one. So here you go. Just so you can see all the different types. I'll open it. These are some good equations you can practice with or share with your students. Here's the 3 ways to write it. So there's slope-intercept form. It's got the strengths for it. Great for finding slope, intercept. Point slope form is easier to create. Did I do it right? y2 minus 1? Yes. And here's your standard form. ax plus by equals c. So those are the 3 ways to write the slopes. Just so you have them. 3 ways of writing linear equations. So you have that PowerPoint. Nice. Okay. So sorry, let's get back into it. I just want to always give you resources. So this one's really easy. So we know we have 16, 9. Remember x before y like the alphabet. So this is just going to be 16 minus y. Pretty sure that's how you do it. I haven't done one of these in a while. Do I have them in here? Oh, it's y minus y1. Oh, sorry, I wrote it wrong. Okay, it's fine. We all make mistakes, right? I just made one. So it's y minus y1 equals mx minus x1. So we already have the x and the y, so it's y minus 9 equals our slope, which is 1/6, x minus 16. There it is. Use point slope form. Yeah, this is point slope, not intercept form. So I think that's what they want. Y minus 9 equals 1/6, x minus 16. But no matter how you write it, it's still the same thing. I always write it in y-intercept form. That's just my way of doing it. Sweet. There we go. All right, graph the line and then write the equation. Cool. So we have the point 1, 2, 3, 4, 1, 2. We have the point 8, 1. Notice we already have the intercept, which is -5 minus 5, and we just need the slope, which means we're going to rise up 1, rise up 1, 2, 3, run over 1, 2, 3, 4. It's positive because we're going left to right, so it's 3/4 x minus 5. Ta-da! Okay. And we're not going to do one that's just diagonal only. I'm going to take that out. Let's see what they give us for this one. Oh, write the equation of a line that passes 3 points. Put your and simplify unless it's a vertical or horizontal line. Okay, so let's do it. Right, oh, we just have to write an equation. Oh, but they want it in point slope form. They want it in point slope form. So remember that's y minus y1 equals mx minus x1. They haven't asked us for standard form yet, which is okay. We just need the slope first. And you can pick any point, which is nice. But the slope is change in y over change in x, which is -8 minus 9 over -2 minus 5. This is going to be -7 on the bottom. And -8 minus 9 is -17. So it just becomes 17 over 7 positive. And we're just going to pick the first one, right? Who cares? I like 5, 9. So y minus 9 equals x minus 5. Wouldn't matter which point you use. 9 equals 17 over 7. X minus 5. Ta-da! Ooh, and they give us the graph too. Oh, now we get a regular one. Cool. So now we have it in standard form. So find the x and y intercepts of the graph. All right. So we did this before. Remember x-intercept, your y equals 0. You solve for x. Your y-intercept, your x equals 0. You solve for y. That's it. So we have 5x minus 6y equals 20. The first one will make this one 0. So we're finding the x-intercept. Divide by 5. X equals what? 4. And this one, we're going to make this 0. Divide by -6. Y equals 20 over -6 or a -10/3. I think the points are better, but that's okay. Those are the points. We did it. We did ours this algebraic way instead of graphing the 2 points or writing the graph and finding it. All right, let's do a matchy match. Which one makes this true? I'm assuming they want us to use the intercepts, which is fine. All right, so our y-intercept is 12, right? When x is 0, we should get a 12 for y. When x is 0, we should get a 12 for y. This one, when x is 0, boom. Oh, let's see this one. Okay, these are both the same, right? However, we want it to be a negative slope, so this has to be on this side. So that's why it's this one. Going down, when I'm putting the slope intercept form, the x becomes positive down here. You can try your best on these, or you can plug it in. Oh God, that was so much work. You plug them all in, you'll see only one of them is true. All right, so drag this. Okay, so here we go. 8x minus 4y equals 40. Let's just do it how I'd normally do it. I'm going to subtract 8x from both sides. I got -4y equals -8x plus 40. I'm going to divide by -4. I love it this way because it just gives me everything I need. 8 over 4 is a positive 2x. 40 over -4 is a -10. This guy's got to drop all the way down to -10. And my slope is up 2. Oh, so up 2 over 1. Really? Up 2 over 1, up 2 over 1, up 2 off. There she is. So it's 5. It's the other one. You can work it out any way you want. They want you to do it the intercept way. I just did it that way. I hate doing the same problem. Again, that looks the same. All right, let's do one with our fancy table. Ooh, we got a toughie. All right, so graph the line of negative 2/3 x plus 5 using the table of given values and following instructions. Plot at least 2 points from the table. Okay, let's plot the point. That one's scary. Let's do negative 6, 9. Cool. And let's do 0, 5. Cool. Plot at least 2 points. Done plotting points. Click and drag to draw your line. Ah! May I undo this? You may draw your graph all at once or pieces. How do we erase? Undo last, undo last. Cool. It's so hard. There we go. Sure. What? Oh, they wanted me to go all the way across? You gotta give me credit. Ugh, let's just do it again. It says only graph 2, right? At least, oh, but I gotta go all the way from one side to the other because it's a line. A line, just so you know, it's different. I know this is geometry. It's different from a segment or array. AB, it's got the arrows, extends infinitely in one direction. This means it stops. It has 2 endpoints. The array, that's its endpoint, and it goes on forever in one direction. AB, AB. Cool. All right. Let's do negative 620. Well, that's not on the thing. 0, 2, beautiful. 1, negative 1. Negative 1, 5. Negative 2, 8. 3, negative 7. 10. Oh, that's off the screen. That's off the screen. I think that's enough. All right. Cool. All right. Well, that was a pain in the butt, but I did it. Just give your kids a ruler. All right. No table given. Oh no. So here's the same idea, but with no table given. They want us to plot points. The first point we're gonna plot, if this is 0. Oh man, there's so much happening here. Okay, here's our equation. So if I plug in 0, let's do, I don't know, negative 3, negative 2, negative 1, 0, 1, 2, 3. Let's just do that. So let's do the 3 and the minus 3. So 3 minus 3 is 0. 0 times this is 0. So the first one is 0, 5. Sorry, 3, 5. 3, 5. Cool. And I think that's our slope. I think it's going to be 2/3 the whole way through. This means I can rise up 2, run over 3. That means I can go down 2, run over 3. Did I just cheat the system? I sure hope so. 1, 2, 3. Down to 1, 2, 3. Down to 1, 2, 3. Up to 1, 2, 3. All right, well, we got to try one of them. If I plug in a 0, will I get a 3? 0 minus 3 is negative 3. 2/3, boom. This cancel becomes a negative 2 plus 5 is 3. Yes, it's correct. I just plotted 1, and then I literally just did the slope because that's in front of the x. That's how I did it. Come on. I need a just a little piece missing. There we go. Ah! Oh no. Come on, be my friend. All right, we should be good. Wild. 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 So I plotted all the whole numbers. 2 to go. Use technology. Ooh, Okay, well, we don't have technology, but we got a brain. Should be all we need for this. I'm gonna add 3 to this side. So it's negative 2x plus 3 equals 3y. We're gonna divide by 3. Y equals, that's a plus 1, and that's a negative 2/3 x. We got it. Boom. Up 2, back 3. Up 2, back 3. Up 2, back 3. Down 2, over 3. Down 2, over 3. Down 2, over 3. That should be all of it. Oh. Oh, I gotta stop at some point because my skills aren't what they used to be in drawing a straight line. We did it. And finally, this is just to lead us into the next one because graphing inequalities was so hard. So this would be a little preview. I showed you this before, but boom, boom. This means we got dotted lines. This means we're open circles. This means we're closed dots, solid lines. We're going to do tons of these, but basically, we're starting at -5. I'm going to go up 1, 2, 3, 4, 5 over 1, 2, 3, 4. Now it's solid, right? Change line. This would be if it's like this, just end equal to, but it's solid. And now we just have to put in the shade. Let's put in the shade. Nope. It is less than. So less than for what? Under the line. Beautiful. We're going to do tons of it. But that's everything. Beautiful. All right. I hope this video was useful. I hope those little extra pieces were useful too. And have a great day.